This is the diagram. This is your lane 101.0. Lane users are connected to this switch. Right now I'm having only one lane user just to prove this practical. Now this lane user can reach core, which is 11111, either via R1, via R2 or via R3. These three routers are working as a gateway in this network. As you can see onto R1 that it is learning 111, and you can reach it from here. From R2 as well you can reach, from R3 as well, which means that from the lane users you can access your core either via R1, R2 or R3. Now it will be depending on your default configured default gateway. If you are using default gateway as 101.1, your traffic will go via R1, right? But the problem is, like, if you are having redundant gateways, will you be able to use them? You just need to confirm that, right? So let's move on to this lane user. I configured its default gateway as 101.1, and then let's try to do trace route 1111. Let's see from where it will go. So it is going via R1. Very good. It is going via R1 because 191.68.1.2, you see this is core. Now the point is, if this interface goes down onto R1, lane interface, let's say that this gateway has gone down, will it be possible for your lane user to go through via another gateway? Will it be really possible for your device, to your lane user, to use another gateway? Vishwanath? Of course it's not possible, right? Because it will always try to look at that gateway only that is configured by you onto this device, right? So you configured 101.1, so definitely at every time to look for 101.1 only. Now if you want to go via R2, then you have to change your default gateway. You have to make it 2 now, and now you will see that, see, you are going via R2. But the problem is, will it be really possible for you to doing all these things? I mean, to do all these things in a enterprise network, like where you are having thousands of users, gateway down, just go to, move on every end user and change their default gateway, right? That's not going to be possible, right? To solve this problem, we are having a gateway redundancy protocol. We are having here that's known as exactly FHRP, first hop redundancy protocol. First hop means gateway. FHRP is nothing in itself. Actually under FHRP we are having some protocols such as right. Basically FHRP is responsible to bundle your multiple gateways into a single logical gateway. If you are having multiple physical gateways, with using FHRP you can combine them into a single logical gateway. For doing that you will be using Hsrp, right? If you talk about the Hsrp, first thing is what? Cisco proprietary. Hello interval is, hold is, multicast address used by it, UDP port number, total group supported by 256, range is from 0 to right. Default preemption is which means that once any router will become active for your group, it will remain as active until it goes down. right? But you can enable it, right? You can enable preemption. Default priority is 100, right? Then in Hsrp we are also having some states. 3 seconds. Hsrp states such as disabled means when you are not using it. And listen, it will be listening from its neighbors. Speak, it will start to speak out. Standby, active is active. Remember that in for a single group, only one can be active, only one can stand by, rest will in listen state, will be in listen state. Fine guys. Now how do they elect? If Hsrp is enabled onto all devices at same time, then first of all higher priority. If it is common, higher IP address. Right? But if we enables Hsrp onto one router, then it will become active. Then after some time, if we enables what Hsrp onto other devices as well, onto the routers as well, then they will not participate in active router election, because preemption is by default disabled. Once anyone have become active, it will remain active until it goes down. But after enabling preemption, higher will be preferred, but IP will not be considered. Higher IP can be considered in Hsrp only at that time when you are enabling Hsrp onto all devices at same time. Then after only, let's say that now you enable preemption, then only and only it will take decision based on priority. Now let's say that priority is same, then now the router which is active will remain active, because based on higher IP address it will not elect active router. Yeah, if you are enabling Hsrp on 2 all devices at the same time, it will be based on higher IP address.
Preemption से priority पे काम करती है.
In Hsrp, preemption will work based on priority only. A router with having higher priority will be active. So now I'm going to configure virtual IP here for virtual gateway, right? So I'm going to use virtual IP as 192.168.101.100. Right, guys? And you know very well that what is the virtual gateway, virtual MAC address for virtual IP. It will always start from 0, 0, 0. (5A), 5E, and then group number access 0C07. Is not it for VRRP?
No, sir, 5E here AC.
That's what I was thinking. A C X X. Right? We will see that. So right now I'm going to enable it onto all devices at the same time so that we can prove that okay onto, right? So I will say standby. You can take your your group number in between this. If you directly define your IP, then it will take its group number as 0. So group standby 1 IP, and then your virtual IP is going to be so at the same time, it means that within hold down timer, I have enabled Hsrp onto all devices. So this time, first of all, they will compare their priority, and then they will compare their higher, IP address as well. AC. See, R3 have become active. So standby. It is active. And see 0000 0C07 AC, right? And last 2 digits will be represent your group ID. So I took 1, that's why it was 01. So standby. It have transition into standby state. And here it must be in listen state. Our interface is still down actually. That's why it was in init state. I get a point. And now here, as you define your default gateway as 101.2, in place of it configure your virtual IP. So remember that if you are using your default gateway as virtual IP, now your traffic will always go through that device which is active for that virtual IP. So right now, who is active for that virtual IP? So right now, see, this R1 is in listen state actually. But one more thing I would like to tell you, that preemption is by default disabled for active router election, but not for standby. For standby router election, let's say that you are going to perform election for standby router, preemption is by default enabled, and it will, in that both components will take place, higher priority or higher IP address for standby router election. Like active is elected now, and then after they will perform standby router election.
R1 R2 पे preemption on होगी.
For what? I'm saying standby router election. Standby router election. I'm not saying that on R1 and R2 preemption will be enabled. It will show you in the output preemption only for active router, not for standby. Remember that if you are going to perform, I mean, if you are saying, if you want to see, if you want to check that who will be standby router in this after active, first of all, they will compare their priority and then IP address. The higher IP address will always be standby if priority was same. Now you can move on to host once again, and then you can trace route 1111 from here. So you must go via R3. See, it's not it. Now in case if R3 goes down, and even other like R2 was standby, so definitely the standby will become active now, right? And now who will be standby? R1. Now your traffic from the host will go via R2. Now you went back onto R3 and it came up once again. It does not mean that again it will become active, because active will always remain as active. But there will be standby election in between R1 and R3, and who will be winner now? It means R1 will transition back into listen state. Traffic will still go via R2. Show IP ARP. You will see that in ARP table, the gateway's MAC address is what? Virtual MAC address. And that was your virtual MAC address. In case if R2 goes down, it have become now active, R3. And R1 became standby, but once again it will transition back from standby state to listen state. And traffic will start to go via fine. Move on to R2. Sorry, traffic is going via R3. Yeah, it's fine now. It's fine. Now the point is, see, it has proved that when I enable Hsrp on all devices at same time, then higher IP address was taking place. But now I'm going to enable preemption. I will show you that okay, higher IP address will never take place. Even now also higher IP address is not taking place because R2 became active, and then after I enabled R3, and R3 was still working as standby. It didn't elect it as active once again. As you can see once again, you can move on to R3, shut it down. R2 will again become active. No shutdown, it won't become now active. However, it is having higher IP address. Now you can say me that okay, no sir, preemption is disabled, that's why it is not taking place, right? Now let's enable preemption as well onto all devices. So standby 1 onto R2 as well. But still R3 will not become active. So even after enabling preemption in Hsrp, it will be taking decision based on priority only, right? Any problem in it? Fine. Now actually I wanted to configure, see, as you can see here in this diagram, that R1 is having higher bandwidth, greater bandwidth as compared to others onto its WAN link, which is Ethernet link. So R1 should be active if it is available. Now you can turn on AC. What do we want actually now? That in case if R1 is available, then it must become active. We can move on to R1. We can move on to F0 by 1. We can say standby 1, priority 150, higher than any other, and you see it have become active. And this time I have enabled preemption over here, show standby, and preemption is enabled onto all this device, on this device only. See, I didn't enable preemption onto R2 or onto R3. Show standby, check it out. Oh, here enabled, and here also it should be enabled now, because you have enabled it onto active. So it has informed to others as well that okay, you should enable preemption now, right guys? So preemption has enabled now onto all devices. After enabling preemption, fine, we are on R1, right? In case if now R1 goes down, F0 by 1, so you will see that immediately R3 will become active. Then what is the role of hold down timer if it is coming up immediately? Hold down timer is by default 10 seconds. It didn't wait for 10 seconds. It came up immediately. Tell me. Actually in Hsrp there is a message, resign message. If you are shutting down an interface administratively before, now device, I mean Hsrp will generate a resign message before shutting down your interface, and that resign message will be multicast, so it will be received by standby, and standby will immediately come to know that okay, active have resigned, so it will immediately announce itself as a active. But in case if this device goes down, let's say you are now shutting down the interface, right? In that case, it won't be possible for this device to generate a resign message. At that moment, standby has to wait for next 10 seconds. There are two different things. You are shutting down manually your interface. Second, your device is going down by itself. In both cases, convergence time will be different. If you are shutting down your interface manually, then it will generate a resign message, and after receiving resign message, it will standby router will immediately transition into active state. Any problem? Sure. Good. So now your traffic will start to go via R3. Fine, no problem. If you move back again onto R1, say no shutdown, and you will see that again it will come up immediately and it will become active now. See, it have become active, and once again the traffic from the lane users will start to go via R1. That's incorrect. It should not become active immediately. Might be that this interface is flapping. So there should be some delay. So we can configure preemption delay as well onto R1, because this is my primary active. So go to F0 by 1, say standby 1 preempt delay minimum 30 seconds, or what do you say, 20 seconds. It is always in seconds. Let's say we configure 20. So in case if it goes down, and if this interface, if everything is fine, then it will not become immediately active. It has to wait at least for 20 seconds before announcing itself as a active. So standby. Right? Once again, what will I do? I will go to F0 by 1. I will shut it down. And once again, your traffic from the lane users will start to go via R3. Onto R1, say no shutdown. This time you will see that it will not become active immediately, no? 17 seconds are remaining. 14 seconds are remaining. Before that it will become standby, right? Because there is no preemption delay for standby election. So it have become standby, but finally it will become, see, 0 second remaining. Now it have become active. It has become now active, right? So this is the advantage of enabling preemption and preemption delay. Fine. So this is called gateway redundancy, because now in case if any one of the gateway goes down, then there will not be any effect onto lane users. There will be some outage, but lane users will not be able to understand that outage, or will not be able to experience that outage if they are not accessing any critical application. Like if they are simply surfing internet and all, then they will never come to that, okay, that was happened actually in your network, some failover was occurred. Because this is called failover. Like if one of the devices is going down, it is now another device will take place in place of that device, so that is called failover. So during failover it is taking some time, but end users will not be able to experience that. I hope that you have understood it now completely. Now you can see that we are having here yeah, that's fine that we have configured all these things. We can do that, right? But see, this time I shut down this link F0 by 1, right? But this time onto R1 I'll shut down its WAN link. which is F0 by, I shut down this link. So if I shut down this link, it will not be able to reach now core anymore, but still it will remain as active. See, traffic is going towards R1 and R1 is dropping back. So now you should configure your Hsrp in that manner so that in case if R1's WAN link goes down, then also it should not be active router anymore for this group. Of course, if its LAN interface goes down, then it will not become it will not be active router. But in case if its WAN link goes down, then there will not be any effect. It will remain as active, and it will start to drop all incoming traffic from LAN users. So basically R1 should be active for this group till it is having WAN reachability, till WAN link is available. For doing that, for achieving that, what can we do from R1? Yeah, we can configure track object, right? Like do one thing, go to F0 by 0 and then say once again no shutdown. Under track we can call IPSLA, like track 1 and then IPSLA, interface, route and all these things, right? Let's say I wanna track my interface, so I'll say track 1 interface fast Ethernet 0 by 0 and its line protocol. That's it. So whenever its line protocol will be up, track object will be up. If line protocol goes down of this interface, then track object will go down automatically. However, you can also directly say F0 by 1, like standby 1. We are using here 1 track and then fast Ethernet 0 by 0. It will create track object for it automatically now. Show track. I didn't configure any track, but see, its line protocol has tracked automatically. Hello, I simply said under F0 by 1 that standby 1 track fast Ethernet 0 by 0. It have created now track object automatically. So in case if it goes down, like F0 by 0 goes down, we shut down it now. After shutting it down, see track object has gone down. Track object has gone down and show standby. Is it active now? Yes, it is still what? Active. Because its priority is still what? 140. Previously it was configured as 150 and by default decrement is what? Of 10 if your track object goes down. If your track object goes down, then the default decrement value is what? 10. That is why it's now, after decrement its priority is now 140 and still it is higher than others. So it will remain as active. So now you must configure its decrement value so that its priority should be lower than any other device in this Hsrp, in this group, right? You should configure that decrement value so that its priority should become lower than other group members. Because they are also group member, we have also configured this group onto R2 as well as R3. And preemption is by default enabled over there, so they will take over the role of active automatically if you do that, right? So for changing your decrement value, what can we say? FA0 by 1, we can say standby 1 track fast Ethernet 0 by 0 and then decrement value is what? I think I should take it 51 so that its priority will become 99, and this time you see so standby. Now it is 99, right? And it is not now active, it is in listen state, right? And now you see your traffic will start to go via R3. Is not it? Now in case if onto R1 it's when link comes up, it can preempt the role of active, but it has to wait for 20 seconds, right? That was the minimum preemption delay. It it have become standby. It will also become active actually. Yes, it have become active as well. And now once again your traffic will start to go via, because once again its priority have become.
Sir, the F0 by 0 down हो रहा है.
Yeah.
दूसरे राउटरों को कैसे पता चल रहा है?
Actually, it is not informing to all other routers. If its F0 by 0 is going down, then we have to track that interface, right? So what is happening that if its track object goes down, then now decrement value will be 51. So if that F0 by 0 goes down, then its track object will go down, and if track goes down, then its priority will be decremented by 51. So its priority will become 99. Now preemption is by default enabled onto all other devices as well. They will come to know that now this R1 is not longer eligible to become active because that is having lower priority, right? So now R3, which was standby, will become active.
Priority sir, hello वगैरह करके share होती है.
Of course, you can see here that hellos are going and they are using multicast address, UTP port number. Check it out. In every 3 seconds. Capture, stop. One is generating, right? State is what? Active. Port number is 1985. See, hold time, hello time, hold down, priority, group, reserved, authentication is not configured, virtual IP address. You understand? I got it. Now standby is also generating. See, 101.3, it is also generating hellos in every. So this is your virtual IP and all these things, right? Priority is this standby, right?
Sir?
Yes.
224.0.0.2 for it we extension notification all routers.
What?
All routers extension notification.
Yes. 224.0.0.2.
Confusing होता मतलब HSRP का भी.
Why? Why it is confusing? See, if it is sending, see, basically you will enable Hsrp onto lane interfaces, right? And if it is multicasting with using 224.0.0.2, which means for all routers, and if it is using .1, which means it will also be received by lane users as well, PCs. However, there is no requirement to send Hsrp messages towards them, right? That is why they are using this .2. In OSPF, did they get? I mean, did they get any confusion at that moment that when you enable OSPF over there or EICRP or ping or whatever it was? So why will they get any confusion over here? .2 means for all routers only. So if R1 is generating any hello message, it should be received by R2 as well as R3. Okay. That is why it is using this multicast address. Yes.
It's also having a multicast address of 102.
In version 2. Even GLBP is also using the same multicast address. 102.
Version 1, version 2 compatible with each other?
Yes, you can convert them. Right? So in this way you can see that all these things are happening over here. And hellos will be generated by active and standby only, whereas your passive state is sending only advertised message. See, it is advertising that it is passive, which means it is in listen state. It is in listen state. Any problem? Now, in case, see, once again it have become active, right? Now the problem is when it created this default track, it considered its line protocol only. What if the problem is existing at the end of code? Here your interface line protocol will remain up. So how will you solve that problem? To solve that problem, what can we do? Onto R1 itself, we can create another track object here now. Track 10. Track 1 was already configured, right? Track 10. Right, track 10, and then after we can say IP route. We can track that route itself, and fine. Then we can go to F0 by 1. Then we can say standby 1 track 10, and then decrement value. Decrement, it should be 51. So that in case if that track goes down. See, now there are two tracks. You can see here, show standby, that I'm using two tracks. Track this and track this. This is the default track which is created by Hsrp itself, and this time I configured this track object externally. So in case if its interface goes down, then both tracks will go down, because it will stop to receive that route, and also this line protocol of this interface will also go down. But in case if this is, yes, no, it will perform only one decrement at that moment. You can see that. I mean, you can check it out. Exactly, that's what I'm saying. But the problem is, if there is any problem at the end of core, so here line protocol will remain up, but the thing is, it will stop to receive that core prefix, right? So if it does not receive that prefix over here, then also track object will go down. Apart from that, you could also configure IP SLA as well for monitoring. IP SLA 1 ICMP echo to whom? Source IP is going to be 192.168.1.1 as we are using here, right? Frequency in every 5 seconds. By default, it will send in every 60 seconds. IP SLA schedule, and it is 1. Start time now, lifetime. Create track object, let's say 50 RTR, and then your SLA number was 1. Just come outside. Show IP SLA statistics. Return code is okay. Successes are increasing. Show track. It is also up. Do one thing. Standby 1 track 50 decrement. So even now, if it is having that prefix in its routing table, but in case if someone have blocked ICMP, then also track object will go down. Show standby.
तो माइनस में हो जाएगी सर,
right? Understood? So now in case if like at the end of core, this Hsrp, what can we do? We can say access list to 1, deny host, then 1 permit any router Hsrp 100 distribute list 1 out F0/0, so that it will not advertise this core prefix towards R1. Move on to R1. Is there any 111 now? If it is not that, then now it means that your track object will go down. See, 50 have gone down. Some other tracks will also go down. See, reachability is what? Down. Track 10 has also gone down. So standby. Check it out.
48.
Right? Fine, guys. So it is not active now. Once you will solve that problem, move on to R4, core router, and remove Once again move on to R1. See, your track objects will come up now, because that route will come here, and also it will start to ping with that. So stand by. It will take some time actually, because preemption delay was 20 seconds. 10 seconds are 4 seconds are remaining. Now it will become active, right? So in this way you can configure tracking and all. Then after, if you want to change its timers, it is also possible. Go to interface F0/1 where you configure this standby. So standby one timer in milliseconds or in seconds. First of all, it is hello interval, right? Milliseconds, like in every 500 milliseconds I want to send my hello. Then hold down interval. If you want to configure, you hold down in millisecond itself, then make it 1500, which is 1.5 seconds, right? If you do not want to change it in milliseconds, you want to change it into seconds only, like 1 and 4. Fine. You can also configure authentication like a standby 1 authentication, MD5 keystring, keychain. You have to create keychain so that you can configure rotational keys, right? But in keystring you will be defining only one key. Now authentication will get failure, and now multiple routers will become active. See, right, for the same group, and that should not happen actually. In same manner, I'll move on to so that once again there will be only one active router.
So multiple routes.
What?
Multiple router कैसे ठीक हो जाएगा?
So in this way you can do all this configuration.
दो अलग ग्रुप हो गए,
Not two different groups. For same group
ऐसे काम कर
we
रहे
were having what?
वो भी एक्टिव है और वो भी एक्टिव.
That's why I'm saying that there will be a problem, right? Like if you do not configure this authentication over here onto R3, let me do that. Interface FA0/1 and remove it from here. Sometimes it is going via, and sometimes actually it will be a problem. Your switch will start to show you flat, because it will learn same MAC address onto its two different interfaces. That should not happen, because whenever a switch will learn same MAC address onto multiple interfaces, it will show you flapping. So MAC flaps can also occur due to this reason as well, right, onto your switch. Once again it will become standby now. Right guys, then after it we can see here that we can get redundancy, but we cannot get load balancing. Of course you cannot get load balancing, because for one group only one router can be active. Now you could say that okay, no sir, we can do one thing, we can create multiple groups for this subnet, but will it be really possible to define all these things with the help of DHCP server, that okay, for this group of users use this default gateway, for this group of users use this default gateway? Of course no. For a single subnet you will be having only a single default gateway, right? And that will be your virtual IP, single virtual IP. Hey, to get load balancing, what can we do? We can create three different groups for this same subnet. For group 1, R1 is active. For group 2, I'll make it R2 as active. For group 3, I'll configure R3 as a active. For some of the users, I will allocate their default gateway as group 1's IP address. For some users, as their default gateway, I'll be using a group 2's address. And for some of the users, I'll be using their default gateway address as group 3's address, right? So if users are having their default gateway as group 1's address, then they will go by R1 because R1 was active for group 1, and you understand now betterly, right? That we cannot, it's not possible to configure it in production network, right? Production environment. That's the problem. So in this way you can configure this Hsrp. Apart from that, you are also having some other things as well over here. MAC address. You can also define your MAC address by yourself. You understand? Then after it, standby, and then you can also configure this command here. Use BIA. BIA means that as a virtual MAC address, use one in address, physical address. Do not use virtual MAC address. So let's say that now you have configured port security over here onto switch, and you said that maximum one MAC address would be learned onto this port. So if you are using virtual MAC as well as physical MAC, then this port will move into error disable state. If you do not want to let your switch to put this interface into error disable state, for that purpose what can we do? I can move on to router and I can instruct Hsrp to use its physical MAC address only for its group. Are you getting my point? Fine. RP left? I don't think so. We have covered now all of the things, all things related to Hsrp now. Even we can see that it will send resign messages if it goes down. Oof. It will start to use the binary address in place of virtual MAC address. Shut it down. You will see that it will generate a what? Resign message. Where is that? Yeah, this one. Right? Fine. Apart from that, you can also use version 2. However, it is not necessary to use version. Now we are going to implement VRRP in place of it. Let me remove it first. So default interface first net 0 by 1. Right, and no track 1, track 10, no 50, show track. Right, I removed everything now.
Default interface
Default interface fast internet 0. See, it will put this interface into its default state now. It will remove the whole configuration from here, including IP address. Right?
VRRP करो ऐसे कर सकते हैं
ज़्यादा कॉम्प्लिकेटेड लग रहा है
Okay. Let's go for VRRP now. So if you talk about VRRP, open standard protocol, it's not a Cisco proprietary, right? It uses IP protocol number, not port number. And I think it is what? 112. Multicast address is what? 18, yes. Apart from that, hello interval is hold is type of, kind of 3 seconds, actually 3.657 something, right? And then preemption is by default enabled. Right? Apart from that, default priority is 100. There are only two things: master, backup. For master election, two things: higher priority. If it is same, higher IP address. Now you are asking for volume 2, right? Wow.
You have to read. You are getting nervous, so I don't let us finish first one. Then it's useless mind now. We just kept it going.
Right? And all others will always remain as backup. So there will not be any election for backup. So first of all, what happens that all of them will start to advertise themselves as a master, but whenever they will receive hellos from master, they can compare their priority and their IP address, right? And then they will say, no, I'm not master. And one more thing, in VRRP, after election of master, only and only master will be responsible to generate hello messages, whereas in Hsrp, active and standby, both of them were generating hello. In Hsrp, only and only active and standby. If anyone is in listen state, then it was not generating hello messages in Hsrp2, but at least active and standby, they were generating hello messages, right? But here in VRRP, only and only understood? Fine. Now track by default is not there. You have to create external track over here, right? So once again, I'm going to use my virtual IP as 192.168.101.100, right? So I'll start it from R1 F0 by 1. I'll say VRRP and see group address is 12255. It's not from 02255. They can ask you group range in between Hsrp and group range of Hsrp as well as VRRP. So slight difference is there in the range of Hsrp and VRRP. So VRRP 1 IP is going to be now 101.100. Now you will see it will become master. See, show VRRP, and my virtual MAC address will start from 00005E0001. Till here it is reserved. Then our last two digits will be responsible to indicate your group ID. No, there is no state. Only master and backup. Init, backup, master. Init means down. If you have down, init. If you have shut down your interface, it will move into init state. Apart from that, it will be either backup or master. This is virtual IP, and advertisement interval is 1 seconds, and down interval, which is hold down interval, is 3.609. Then we can move on to R2. VRRP 1 IP. It will become master because preemption is by default, and here higher IP address will always take place. It's not like Hsrp that IP address was not taking place even after enabling preemption. So it is master now. Go to R3. Now R3 will become master. See. Right, that will become master C. Fine, your traffic will go via R3. Show IP up, check it out. 5E0000101, right? Show once again trace route. So traffic of all lane users will go via R3. However, when bandwidth is higher onto R1, so R1 should be master till it is up. Now it will become master C. Show VRRP. It have become now. So the traffic of lane users will start to go via R1. In case if R1 goes down, the lane interface, we'll see R2 and R3, both of them will say that master, but it have moved back into backup. But R3 became master and it is still master. So whenever master will go down, all others will start to say that okay, we are the master. But again there will be an election, right? So now you can see that now from host you can try to trace route it and it will go via R3. You can move back again onto R1, you can say no shutdown, and you will see that it will become master once again automatically because preemption is by default enabled. So due to preemption enabled, because by default preemption is enabled over here. It's chilling today. Fine, but again the problem will remain same, like if in case if WAN interface goes down, so directly what will I do? I'll generate IP SLA 1, which is I think already configured. Show IP SLA statistics. Yes, it is already configured, right? So we can create a track object 1 RTR 1. Just come outside. Show track. You understand? Then go to interface F0 by 1. Say VRRP 1 track 1. By default it will be 10, but it will remain as 110, so it should be, yeah, because this time its priority we configured as 120, so that its decrement will be, it will be, after decrement its priority will become 99, which will be lower than others, right? So now show VRRP. Fine. Now do one thing, go to F0 by 0, just shut it down. Track object will go down. Show track. Show VRRP. Right? In case if it comes back up, everything will be fine now once again. Track object will come up, and also it will become master immediately. See, it will become master now. That should not happen, it should wait for some time. There is no preemption delay, so you can configure that. VRRP 1 preempt delay 30 seconds. Right? And now, because it is master, so traffic will go via R1 only from the lane user. Show IP route. Fine, guys. That's the thing. Fine. So track is working perfectly, VRRP is working perfectly, and if you want to see that only and only master generates hellos. So see, only 101.1, which is master, no one else. And IP protocol number is 112, and then you can see. Now authentication, wanna configure authentication, you can do that. It's same as Hsrp. The only thing that you have to change, in place of standby, you have to configure VRRP1 MD5, then either keychain or keystring. It would be up to you. Right? In same manner, you can change its timer. You cannot change hold down timer, but you can change advertisement interval. VRRP 1 timers advertise in millisecond or in seconds. By default, it is already 1 second. So if you want to configure lower than that, you have to configure in milliseconds only. So in this way, you can configure VRRP. So I don't think so that there will be any problem for you in configuring VRRP.
So I have read somewhere it doesn't support IP version 6.
What, VRRP? Yes, it does not support. You cannot configure VRRP for IP.
Hsrp will support IP version 6.
Yeah, it will support.
But
Like,
it's,
see,
it's an open standard now.
yeah, see, standby 1. You have both options, IP, IPv6. But in VRRP, only and only IP.
It's an open standard because usually if it's open standard, it has to support. Normally if it's open standard.
Even OSPF was also open standard. Who said that OSPF was Cisco proprietary? But initially it was also not supporting IPv6. Then finally they launched OSPF version 3. Then it started to support IPv6. In near future they can also launch VRRP newer version which can start to support IP.
No balancing?
Of course no, same as Hsrp, because for one group only one can be master. You can create multiple groups for multiple VLANs. If you are doing all these things, all this configuration onto MLS, then you have to do configuration under SVI, switch virtual interface. Finally, let's talk about GLBP. Because these protocols do not support, I mean, they support gateway redundancy, but they do not support, I mean, these protocols do not support. Tell me. Yes, load balancing. Right? So basically GLBP is that protocol, gateway load balancing protocol. So it supports gateway redundancy, but along with that it will also support load balancing. Right? So if you talk about the GLBP, in GLBP you have mainly two components, AVG and AVF. AVG is active virtual gateway, and AVF is now the election of AVG is same as Hsrp. States are same as Hsrp, and AVG would be simply responsible to provide ARP response. ARP replies in the response of ARP requests. That's the task performed by AVG based on load balancing algorithm. Because in GLBP we are having multiple load balancing algorithms such as round robin, weighted, host, dependent. By default it is round robin. So basically AVG would be responsible to give the response of, I mean, to give the ARP reply in response of ARP request based on load balancing algorithm. Right? And finally, in GLBP, remember that all routers will work as a forwarder. All routers will work as a forwarder. Like you enable GLBP first of all on router 1, so it will become forwarder 1. Then on R2, then it will become forwarder 2. Then on R3, then it will become forwarder 3. And for one forwarder, let's say it is forwarder 1, the actual router which became forwarder 1 would be active for that, and all others would be in listen state. I mean, for forwarders there is no standby. There will be only two states, either active or listen for forwarder. But remember that in a single group you cannot have more than 4 forwarders. In a single group you cannot have more than 4 forwarders. Right? Now we'll configure it tomorrow, because configuration is quite, I mean, slightly different. Do one thing, just read it by yourself once, this GLBP, so that tomorrow it will be